Hello everyone and welcome to a new video about REVEN. In this one we'll have a look again at something we already presented in a previous blog article, but we felt was worth highlighting in its own video. So we're again working on that PE parser crash where an input PE file is read by the kernel, that triggers a bug, and in the end the system crashes. And looking at the backtrace, I see that the crash is being caused by a page fault on a faulting address, and that address is built there by the addition of a base address and an offset, and for now we'll concentrate on that offset. We had tainted that offset before backwards because we wanted to see how it was built, and actually we discovered that it was not built but rather read directly from the input file. And if we look at this input buffer, we see that this is an MZ header, so this is a PE file. So now the information I have is I have an offset that is used by the kernel, directly read from user values, user inputs. And I'm fairly sure that the kernel checks the input values from the user, but probably there's a bug somewhere that prevents the track from being executed properly. So I want to see every time this value there is being compared or checked and try to understand the logic there and find my bug. So I can't do everything, but I can have a lot of information here just by using the forward taint. So this is what I'll do. This is my input value. I'm going to taint it from my current moment in time forward up to the end of the trace. And I see that flags pop up in the result because every time I compare that value or one of its derivatives, obviously the flags are going to be tainted because they depend on that input value. This is the case here, and I'm testing that value against 0. That's not what I'm interested in here because I'm more interested in the upper boundary checks, so I'm going to skip this one. The second one is similar because I'm testing against 0. And finally, the third one is more interesting. I'm testing against something that looks like an upper value. So this is an area of code which I'm interested in, and I wish I had at this point the static view of that because I want to understand the logic. So that's fairly easy to see because I can just open IDA on that kernel and then synchronize IDA on the location which I'm selecting in the action view. And this is what I have here. You see that whenever I move on the left, it also moves on the right. So I have a list of moments in the trace where that value I'm interested in is checked, and I can compare the static view of that same code on the right and moving back and forth between the two views, navigating through the results. I'm able to better understand the code and hopefully find the location of the code where that check is not performed as it should be. So here, to sum up, it's not a case where REVEN gives me a full answer, but rather it helps me narrowing down a lot the work I have to do because it's going to give me hints as to where to look for the bug I'm interested in and try hopefully to find the information I'm looking for. Okay, I hope you learned something today, and as always, thanks for watching.